All right, so starting chapter 4, we're going to talk about polynomials. And the first thing we want to do is just do a quick recap on exponents. Okay, so if we have x to the a times x to the b, if we have x to the a in parentheses raised to the b power, if we have x to the a over x to the b, if we have x to the 0, and if we have x to the negative a. So those are basically our 5 main properties that you're going to encounter. Here's 4, and here's 5. So if we have x to the a times x to the b, we're going to be adding the exponents. If we have x to the a raised to the b power, you're going to multiply. If you have x to the a over x to the b, you subtract. Anything to the 0 power is always 1. And if you have anything as a negative exponent, you can't have a negative exponent, so you have to get rid of it. So what you would have to do is you have to move it to the denominator. So right now, x to the negative a is in the numerator, so you're going to move it and make it positive in the denominator, which leaves you with a 1 in the numerator. So those are the review of all our exponent stuff, which we're going to use in a couple of examples here. So it says a monomial is a number, variable, or an expression that's a product of one or more variables with non-negative integer exponents. So for example, 5b, that's a monomial. Negative w, that's a monomial. The number 23 is a monomial. X squared is a monomial. 1/3 x to the third y to the fourth is a monomial. It's a single term. Nothing is being added or subtracted to any of those values. Now, monomials cannot contain variables in the denominator, so it couldn't look like this. Variables with negative exponents, so you could not have something like that. Variables under the radical, so you can't have anything that looks like that. And you can't be adding or subtracting between terms, so you can't have anything like x plus 8 or x minus 8. So to simplify an expression containing powers means to rewrite the expression without x parentheses and exponents. So this is where our rules are going to come in. So we're going to simplify each one. So we have 3 things being multiplied here. So I'm going to take all the leading coefficients, 4, -3, and a +1, and multiply them. So I get -12. I am using rule number 1, where I will be adding the exponents together. So -3 and +2 get me a -1 for a. B to the fourth, C to the -1. And then the only thing you have to be careful of is you can't have negative exponents. So I know I'm going to have a fraction. The -12 is in the numerator, and the B to the +4 is in the numerator. The A to the first has to move to the denominator, and C to the first has to move to the denominator as well to make it positive. For B, we have a squared to the third over a to the 10th to the third. So if we multiply, we get a to the 6th over a to the 30th. And then this is your division rule, so we're going to subtract. So we get a to the -24th. And then you can't have a negative exponent, so we're going to put it under 1. So 1 over a to the 24th. All right, with C, what I would suggest doing, and you could have also done it for B, simplify the fraction first. Just going to allow you to do a lot less in the meantime. All right, so if we simplify our fraction, 8 over 16 is 1 over 2. If we have a to the third over a squared, that's a to the first in the numerator. If we have b to the second over b to the third, that's b to the first in the denominator. Then you only have 1 to the fourth, a to the first to the fourth, 2 to the fourth, and b to the first to the fourth to simplify. So that gets us 1 to the fourth is 1. That's a to the fourth over 16b to the fourth, and that's your final answer. With D, remember anything to the 0 power is 1. So this is 1 minus 4 times 1. So 1 minus 4 gets us a -3. Now with a polynomial, that's the sum and or difference of more than one monomial put together. So this is where the adding and subtracting comes in. Every term in a polynomial must be a monomial. The degree of a polynomial is the same as the degree of a monomial term with the highest degree. And we're going to add the exponents of each monomial term to determine what that is. Let me show you. So it says determine whether each expression is a polynomial And if it is, state the degree of the polynomial. And then I'm also going to add, be able to explain if it is not a polynomial. So always be able to have that understanding behind you in terms of why or why not. All right, so looking at A, we have two terms there. The first term, that would be a monomial. The second one, that would be a monomial, and you're adding them or you're subtracting them. So yes, this is a polynomial. So that part's good. And then what we have to do is we have to determine what the degree is. So the degree is based off of the exponents. So this second term, we'll do that one first. That's just 4 because the exponent's 4. Whereas here we have a 3 and a 5 that we have to put together. So that would be equal to 8. Therefore, the degree of this polynomial is equal to 8. You add up the exponent values. For B, x is fine, 5 is fine, but radical x is not fine. So this is not a polynomial. You can't determine the degree if it's not a polynomial. So now you just say why it's not. You cannot take the square root of a variable. So you're basically taking the reasons that were on the front page of the notes and just justifying. For C, we've got two terms. Both of them are polynomial or monomials. So yes, this would be a polynomial. And in terms of the degree, if we look at each one, well, this one has a degree of 2, and this one has a degree of 7, which means the higher one wins, which would be 7. Now for this last one right here, we have x to the third, which is good, and 9, which is good. So yes, this is a polynomial. And then your degree, so if we're adding exponents, this would be 3, and there is no exponent here, so that's 0, which means the degree of 3 would win out with that. Now when you add or subtract, what I would recommend is you have to combine like terms, but in order to do that, you got to get rid of these parentheses. So you want to rewrite it without the parentheses. So if it's an addition problem in between, nothing's going to change. So you just rewrite each of the terms, and then you combine like terms. So 3x squared and 3x squared and x squared makes 4x squared. Negative x and plus 4x makes 3x. And 2 minus 9 gets you a negative 7. What changes with subtraction is that second term, you have to distribute that negative sign. So that's going to be distributed to each and every one of those terms. So 9r squared minus 8r squared is r squared. 6r minus 7r is r. And 16 minus 10 is 6. And you want to just always make sure you're writing your answer in descending order in terms of the exponents. All right, for this final set of examples, it says you can use the distributive property to multiply the polynomials. The one thing you want to make sure to do is the letters are written in alphabetical order. Are written in alphabetical order. And that's saying when you have more than one put together. So we're going to distribute. So 1/2 a to the third times 4 would be 2. And now we add the exponents, a to the fourth, minus half of 6 is 3. A to the third b would be a to the third b. You don't write it as b, a to the third. Half of 8 would be 4, and then you have 4 a's and 4 b's. So again, what I mean by alphabetical order is that the a comes before the b. The a comes before the b when they're next to each other. For example, B, we have 4. We're not going to write CB squared. We're going to write B squared C. And we're going to write minus 4 BDZ. So the letters are in alphabetical. All right, for C and D, we got to FOIL these guys. So we get 15y squared plus 12y plus 10y plus 8. 15y squared plus 22y plus 8. And again, you double check to make sure they're in descending order. So this was a FOIL situation. Same goes here. So n squared times n is n to the third. N squared and 4 makes 4n squared. 6n and n makes 6n squared.